Hello all. Now let us discuss the isometric view of a pentagonal prism. And the question is a pentagonal prism of base at 30 millimeter and axis 16 millimeter long, which is resting on HP on its base with one base at parallel to VP. Okay. So as in all cases, we have to start with the top view. So you can start with one base set, which is parallel to x line in top view because one of the base set is parallel to VP. So the top view of that base set should be parallel to x line. So you can start with one base set parallel to x line and you complete the top view and draw the corresponding front view. So before that, you can name the coordinates A1, B2, C3, D4, and E5, and project all the points and complete the front view. Okay. Then inscribe or enclose this pentagon inside a box and uh, name the coordinates of the box as 1, 2, 3, and 4. So after completing the top view and front view, you can mark the dimension also. Then you can draw a baseline and draw uh, a line 1, 2 by taking the length equal to length of this line such that uh, which should makes an angle 30 degree with this baseline. Okay, and similarly you draw 1, 4 which is 30 degree inclined to baseline by taking the length from the top view. Then locate point 3 such that 2, 3 equal to this length and 3, 4 equal to the line which is measured from this top view. Okay, and locate point 3. Then locate the base coordinates 1, 2, 3, 4, and 5 such that the distance of 1, 1, this distance equal to, so I will show you the distance of 1, 1. This distance is equal to the distance which is measured from this top view. Okay, similarly 1, 2 equal to this distance equal to 1, 2, this distance. Similarly, you can locate point 3, 4, and 5. Okay. The next step is you have to locate the access point P in the base such that the distance of 2P equal to this distance 2P. Okay. First, you project point P into the 1, 2 into the box line 1, 2. So it will meet the point 2 itself. So from point 2, you can draw this line 2P such that 2P equal to this line. Okay, and draw the axis line which is perpendicular to the baseline of length equal to the length of the axis 60 millimeter. That should be perpendicular to baseline because that line is a vertical line. Vertical line means that is perpendicular to XY line in front. Okay, and all the lateral edges, that is 1A, then 2B, 3C, 4D, and 5. These edges are vertical lines because uh, vertical line means that is perpendicular to XY line. So that should be perpendicular to baseline in isometric view also. So you can draw 1A which is parallel to the axis line or perpendicular to baseline of length equal to 60 millimeter. Similarly, locate point B or draw the line 2B, 3C, 4D, and 5. Okay. Then next step is, so we have to identify the hidden lines or dotted lines. So the simple method to identify the dotted line is initially you can join all the points in the boundary line or you can join the boundary lines. So that is, you can start from point 1, 1, 2, 2, 3, 3Z, CD, then DE, E5, and 5. Okay, these are the boundary lines, and you consider the base corner which not comes in this boundary or which not lying in this boundary. So that point is 4. So the line joined with 4, that should be dotted line, that is 3, 4, 4, 5, and 4D, that should be dotted line because that lines are hidden lines. Okay, from the front view, that lines are not visible or that edges are not visible, so we have to represent that lines by using dotted lines. So 3, 4, 4, 5, and 4D should be dotted line. Okay, then all other line that should be represented by continuous dark lines. So AB, BC, and also you can join AE, and there are two more lines, that is 1A and 2B. So this line also should be a dark continuous line. Then axis also should be a dark line, that should be chain dotted line. Okay, so this is the final figure, and also you can represent the arrow head which represent the direction of view of the observer and mark the angle 30 degree. That is, in the case of vertical solid, you can initially start with the box that should be at an angle 30 degree to a baseline. The box should be 30 degree. Okay, 30 degree to the baseline. Okay, in the case of a vertical prism or vertical solid. In the case of a horizontal prism, that is, if the axis is perpendicular to vertical plane, okay, and parallel to horizontal plane, then the box should be at an angle 30 90 degree. 30 90 degree. Okay, then we are moving to the isometric view of a cylinder. So the question is, a base circle diameter of the cylinder is 50 millimeter and height 60 millimeter, which is placed vertical. Okay, so we can start with the base circle and divide that circle into four number equal division. Then name the points as A1, B2, C3, and D4, and also we can represent the front view. Okay, then the center line should be represented by using chain dot line, because that line represent the generator B2, D4, and also the axis line. So when generator and axis line intersect in front view, we can represent that line as the axis line, that line as chain dotted line. Okay, so the center line should be a chain dotted line. Then also you can mark the dimensions, that is the diameter of this cylinder and also the height of the cylinder. Okay, then as I said, the case of external view of a vertical solid, we can start with the box that should be at an angle 30 degree to baseline. Then draw the box by taking the dimension equal to the dimension of the box from the top view. Then locate the center point of this box by drawing diagonal lines, and that point is P. Okay, then you transfer point 1, 2, 3, and 4. That is the midpoint of this box. Uh, so by taking the same distance from the top view, locate 1, 2, 3, and 4. Then uh, we can draw the base curve by a method called force center approximate method. That is a method we are used in the case of the construction of base circle in cone also. So the same method we are following here also to construct the base curve. So for that we have to locate force center. So you consider the shortest triangle, that is shortest triangle of the box, and 1 3 is the shortest triangle. So 1 and 3, that is the end point of the shortest triangle, represent two centers. So 1 and 3, which represent the two centers of the uh, force center approximate method. So we have to locate other two centers also by drawing, by joining the point 3 with 1 and also 3 with 2. Similarly, 1 4 and 1 3. So you get these 2 points also. So in this way we can locate force center to construct the curve. Okay, then 1 a center and radius equal to 1 4. This line you can construct this curve. Okay, initially you can draw this curve as dotted line or continuous line. Okay, then with 3 as center and radius equal 3 1, 3 1 or 3 2. Okay, 3 1 or 3 2, you can construct this curve also. Then this point as center, this point as center, not P as center, this point as center and radius equal to this distance, you can construct this curve. And this point as center, radius equal to this line, you can construct this curve also. So in this way, you can complete the base curve. Then, to in order to complete the prism, isometric view of the isometric view of the cylinder, we have to consider the curve at a height. Curve means the base curve or the circle at the top of the bottom curve or bottom base curve. So for that, we are using a method called box method. So initially, you complete this box by taking the height equal to the height of the cylinder. So you first locate point 1 such that 1 1. Draw a line from 1 that should be light line such that length equal to the height of the cylinder. Similarly, locate 2. Same naming can be given at the top also. So 2 2 equal to 60. Then 3 3 equal to the height of the cylinder and 4 4 equal to the height of the cylinder. Then join all this point to get this box at the top. Okay. Then you locate point A B C D, that is the midpoint of the cylinder. A B C D at the midpoint of the cylinder at the top. So A B C D, after locating A B C D, you can construct the curve by locating the force center at the top also by same method that we are used in the used for the construction of bottom base circle. You can use the same method for construction of this curve at the top also. Okay, so for that you initially locate these force centers and complete this curve. The next step is you can draw the tangent line, tangent to the upper base curve and lower base curve like this, and also on the right side, and also you represent the center line as axis line as chain dot line, uh, and you complete this figure. Okay, so this is the final figure, uh, and also you represent the dot arrowhead to represent the direction view of the observer, mark the angle also. And when you construct this box, that should be represented by using thin line. Okay, only this isometric view of the cylinder should be represented by using dark curve or dark lines. Okay, so this is the fine figure. I hope you understand. Okay, thank you.